So solving system of variables, there's our objectives and our academic standards for today. Now, an equation with three variables is going to be written as an ordered triple, x, comma, y, comma, z. It's a graph. It's a plane in three-dimensional. So we've been x and y, that's two-dimensional. It's a flat space. The z gives it depth. The z gives it depth. Okay? So, and you can still have one solution, no solutions. Now here you go. Infinite solutions. You're going to tell me all points on the plane, or you could say all points in the line. I like to say plane because we're talking about three-dimensional. And here's the deal. You can't write it in slope-intercept form because it's three variables. So you can just write it in standard form, whatever form's given to you. Okay, Metul? So you'll be good to go now. You can write however you want. Two variable, write it in slope-intercept form. Three variable, just give it to me in standard form. Okay? So I have these steps here to solve. I want to emphasize this. So when we solve this, the goal is to, guys, you have three equations of three variables. Your first step is to break it down into two equations of the same two variables. Let me emphasize it one more time. Your first step is to get it down to two equations of the same two variables. So when I look at this one works out really nice for me. If I would add equations 1 and 2 together, what would cancel? The z. So let's do that. Let's go up to the side here and let's get one of our two equations. So that's going to become what? 2x plus 2y equals what? 2? Okay, there's one of my two new equations. Come back over here now. I also could add equations 2 and 3 together. And wouldn't that also cancel out the z? And then I would have what? 4x minus y equals -1. They're doing that okay? And now, so here, now we got it down to two equations of two variables. This is exactly like what you've been doing now. We're going to look and see if we can eliminate either x or y. I think it makes most sense, since this one's positive and this one's negative, to eliminate y. In order to do that, Mr. Riffle, what would I multiply the bottom equation by? 2. So let's multiply that bottom equation by 2, which becomes 8x minus 2y equals -2. So we're going to add these two equations together, which gives me 10x. Let's see if I can write. 10x equals 0. Did I do that right? And so therefore x is equal to what? 0. And now, look up here on the screen. You need to work backwards. You plug the 0 in to one of these equations right here that only had two variables. You'll follow me on that? So I plug in the 0 here, if you will. That would give me 0 plus 2y equals 2. So 2y equals 2. So therefore y equals what, guys? 1. So therefore y equals 1. And then, follow me here again, I'm going to take these two solutions and go back to any one of these and plug in. It makes most sense to keep the z positive, plug it in right here. X is 0 plus y is 1, so 1 plus z equals 3. So z equals 2. And you're going to write it as the ordered triple x, comma, y, comma, z. And don't be a ding-dong and go, how do you know what order? Alphabetical. John? Yeah, I mean, you could have done that first, absolutely. And then you've done 1 and 3, same thing. There's multiple strategies to do it. The key is, at the beginning, go from 3 equations of 3 variables to 2 equations of the same 2 variables. Okay? That wasn't bad, was it? Okay. Now, this one can look intimidating, but it's not. I understand most of you don't like a fraction. Is that safe to say? You guys were beaten with them as children for fractions. Your parents threw fractions at you as a child. Okay? So let's clear fractions on this bottom equation by multiplying everything by what? 2. So let's multiply this bottom equation by 2. So when I do that, it now becomes what? Negative 2x positive 4y plus z equals, the mistake, if a student makes a mistake, here's the most common. Look up here. The most common is they forget to multiply all the way across. Negative 2. Okay? So this equation doesn't exist anymore. Now, why is this a nice equation? Taylor?
Because if you do the third one with the second one, it cancels everything out.
So when we add these 2 equations together, I get 0 equals 0. Now, hold on. Verify a little bit further. You need to check with the other way too. You see what I'm saying? Just because 2 equations, you got to see if it all of it matches. So what if you look up here? You probably do this in your head. If you wanted to add 1 and 2 together, if you multiplied this one by 3, wouldn't that give you the opposite of everything? And that would also give you 0 equals 0. I'm okay now. Mitul, would you like to answer the question for me?
All points on the line.
Or infinitely many solutions. That it?
No.
On
The line.
I would like, it's not wrong if you say line, but it's a little bit more detailed than that. All infinitely many solutions on the plane. Spell plane correctly. Okay? A mathematical plane. On the plane,
And then just say
any of the equations. It doesn't matter which one. Let's grab that middle one. It looks the prettiest to me. So on the plane, 2x minus 4y minus z equals 2. Taylor, you have a question, hon?
How do we write that in the notation? Or do we not need to?
You wouldn't. You can't. You're talking about interval notation?
Yeah.
Yeah, you can't answer that in interval notation.
Okay.
Okay.
If we had
So maybe let me hit pause on my recording. 3 equations of 3 variables. Let's develop a game plan to eliminate a variable. And it does not matter which one you want to get to. Okay? I just want to get it down to 2 equations of the same 2 variables. Is everybody clear on that? All right. So what do you want to do? There's not wrong. Ms. Wiseman, you look like you're just dying to talk right now. Okay? Am I reading you right?
I don't know.
That's pure sarcasm by my point. But anyways, what do you think? What do you want to attack?
I want to get rid of Z.
You want to get rid of Z? Okay, I'm with you. And let's do this then. The first time, let's multiply the middle equation by -2 and add it with the first equation. Would you all agree with that? And then, hold on, listen. The next time we're going to come back here, look up here. I'm going to multiply it by, this time by -4 and add it with the third. Everybody agree with that? So everybody do that right now and get your 2 equations of same 2 variables. So I got it down to these 2 equations, doing what I said to do. And now I'd say let's eliminate x by multiplying this the top equation by 2, which would give me 2x plus 8y equals 4. So now when I add these 2 equations together, it gives me 19y equals 19. Well, that worked out nice. Y equals 1. Now, let's pause for a second. Everybody look up on the screen, please. Once you have this one, I work backwards. I plug it in where there's a 2 equation, 2 variable. Makes most sense to plug it in right here, would you agree? X plus 4 times 1 is 4, subtract 4, x equals -2. Then I can go back to, it makes most sense, look up here. It makes most sense to plug it in this middle equation because z has a leading coefficient of 1. Agree? So -2, and then -3 times y, -3. I know you could have done that in your head. Plus z equals -2. -5 plus z equals -2. Add 5, z equals 3. So our final answer as an ordered triple is what? -2, comma 1, comma 3. Now I'm going to hit pause for a second. Works out actually really nice because you already have it one equation of 2 variables. So which variable is missing?
X.
So shouldn't you get the other equations added together, get rid of that x as well? And I would probably do that I would just subtract. But look up here. I'm going to take the equation 3 minus equation 2. Equation 3 minus equation 2, and that would give me what, Shirley?
What?
Equation 3 minus equation 2 becomes...
So like 6y minus y? Or
Yep,
the other way?
yep. What you said,
So 5y.
5y
minus 7z
minus 7z.
equals 20.
Nice. And then look, I have this and this. What guys, look what happens. If you subtracted 0, 0, 0 equals either 6 or -6, depending on which way you went. Does 0 equal 6? You're right away, your answer is what? No solution. Which means you have 3 parallel planes or lines. So like this one here is a line, and this line is parallel to these 2 planes. They never intersect. This is your homework. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 problems. You get after it, you may get it done before you leave today.